Hi there, everybody. Welcome to Chem Complete. And in today's lecture, we are going to take a look at the difference between descriptive and inferential statistics. So if you are in a statistics class and you are trying to figure out the difference between these two in some of your opening statistics lectures, stay tuned because we're going to answer that on the channel right now. Okay, thank you so much for learning with Chem Complete today. Let's get started with a discussion about statistics. Now, before we dive straight into descriptive and inferential statistics, it is important to understand two main terms that are going to come up in statistical analysis, and these should be really discussed or looked at before you really get into any deep statistics, because you need to understand the difference, and you also need to understand what parameters you're setting yourself up within whenever you're getting ready to start a study. So those two terms are population and sample. We're going to take a look here just to kind of help define some of it and give some examples. All right. So a population is going to involve all subjects that are being studied. Another way that you could say it is all subjects of interest to the research or the researcher. Now, a population can vary in size. So you can have a lot of different ranges. For instance, you could be interested in all humans, or maybe a subset of humans, so you're only interested in humans within the United States, or something of that nature. It could be all students at a specific school. So let's say that you have a given high school or a college or university. Every single student, every single professor at that particular institution could be a population if you're only interested in data from that specific school. All senior students at that specific school. So maybe you're looking, let's say for a high school, you're doing some research about a specific high school, and the in-house research is looking at college acceptance rates or something of that nature. And you're only interested in looking at the seniors, and so they could be your potential population. Right? And then we could get even more specific. You could be looking at all senior students at a school that are currently taking a statistics class. So you can see we're kind of going from a global span, all humans, down to an entire population at a school, down to a specific subset or grade or graduating class at that school, all the way down to an individual classroom and the number of students that make up that class. So it really depends on what you are interested in. However, what I would state is that if you are going to say that you're studying a specific population, you need to have good reason as to why that is your population and why you are interested in that. Okay, so many researchers, the reality is we're constrained by the finances, by the location, by the ease of samples, and so forth. And so let's say that you wanted to run a nutritional study, and that nutritional study should really be looking at all human beings, but you're just going to sample people that are in your specific class. Well, if that is your population, then the question becomes, why are you interested in the nutritional habits or the nutritional outcome for certain events only to your statistics class? That seems a bit bizarre, right? So don't confuse your limitations with what the actual population should be. Now, moving on to sample, okay, let's face reality. Most of the time we're interested in relatively large populations. And so because of that, it can be very difficult to gather all of the data, if not near impossible, right? So how do we get around this as statisticians? We use samples. So a sample is going to be a group of subjects that are selected from a given population. Most statisticians are going to study a group or a sample that is large enough, and that is a bit biased in that term, right? Large enough can be, okay, that's subjective. What do you say is large enough? Most researchers will agree, depending on the research, that about 30 samples should be large enough to, constitute a representative estimation of the population. However, you need to make sure of a couple things, and you can see the note here, specifically that you are randomly sampling. And while we're not going to get into it in this video, you need to make sure that you have a normal distribution. So your population should share a normal distribution, and your sample should be normally distributed. And then if both of those are true, your sample, if you're roughly around 30, give or take, samples, you should be approximating normality, and you should be able to make a generally good approximation of the population at large. Okay, so now let's dive into descriptive versus inferential, which is kind of the point of this video. So the question that we pose to ourselves is going to be, will the study use descriptive statistics or will it use inferential statistics? So what are descriptive and inferential statistics? Let's start with descriptive. So descriptive statistics, as the name would suggest, is going to describe a situation, or it's going to describe the attributes that are among a population or a sample. So take a look at these examples and it should hopefully become clear. What is the average age of a college professor in a specific county? What is the average GPA of a high school student at a given school? These are descriptive in nature. They are describing a situation. They're describing the age, right? Or they're giving a specific attribute, the age, the GPA, among a population or a sample. What they are not doing, what inferential is going to do, is that they are not trying to compare two groups to one another to see if there is a difference, right? So it is very different to say, what is the average age of a college professor in a specific county, versus saying, is the average age of a college professor older or greater in county X versus county Y, right? Those are two very different things. One is just describing that specific age for that group in that county, and the other is trying to see if there's a difference between one county and the other regarding the ages. You can make the same argument with the GPA. So in that case, what is inferential statistics? With inferential statistics, which is what a lot of people see when we see these studies that come out in headlines and things of that nature, is when you are testing a hypothesis and determining relationships among variables within and between groups. So it can be within the same group, and it can also be between two different groups. Okay, so here's an example, and we'll look at this in a little more detail in 1 second here. College students taking statistics class at University X have significantly higher GPA values than those students at the same university not taking statistics, right? So what we're kind of doing is we're taking two groups here, and we are saying, look, we've got college students at University X, and so you either have taken statistics or you have not taken statistics. And based on that, we are going to make the hypothesis, we have to test it, that those taking statistics have significantly higher GPA values than those students that are not taking statistics at that particular school. All right, so what is the population here? The population would be University X students, right? So we're looking at all the students that are at University X. And we are then breaking that down into two groups that we are really testing against one another. We have those that are taking statistics, and we have those that are not taking statistics. And we are seeing if there is a difference in their GPA when we are comparing them to one another. So this is an example of inferential statistics, or a set of data that would be asking or addressing a question using inferential statistics. Now, you'll note I have an important question here. And that important question is, how large is this population? Okay. Now, when I say that, I don't just mean by number itself, although number addresses this concern. What we're really talking about is, what is the population? Are you talking about the current student body and those that are taking statistics there? Or are you talking about all students in the history of that university or school that have ever taken statistics, right? Because at any given time, we're going to have a certain student body that is at University X. And that obviously rotates. We get new freshmen that come in. We get new seniors that graduate and go out. And so the question becomes, are you only interested in a snapshot at the population as it currently stands, right? Today, the actual student body at University X, or are you interested in the entire history, right? So all students, assuming we're keeping good records at University X, we know whether a student has taken statistics or not, and we should also know their GPA when they graduate, or their current GPA if they haven't graduated. And so you have to keep that in scope when you are defining or asking your question, right? Because those are two vastly different populations. Even though they both stem from University X, one is looking at the entire student body that's ever passed through and is currently going through attending at University X, and the other one is only looking at the current population, or those that reside at University X right now, freshman through senior. So it is important to define population and sample, and that's why I led with that. Instead of just diving directly into descriptive and inferential statistics, I wanted to talk about population and sample, because it is very important when you're getting ready to ask these questions, especially the inferential questions. What is the actual population? What are you talking about? And be specific. All right, so that covers the differential versus the descriptive versus inferential statistics discussion. And I thank you very much for learning with Chem Complete today. You can head over to chemcomplete.com and check out any of the free resources that we have over there. And if you liked this video, you found it helpful, be sure to leave a thumbs up. It helps with the algorithm. And if you subscribe, you will stay up to date with all of your needs, whether they are statistics, chemistry, or some other STEM-related subject, as more info is released on the channel. So thank you again for learning with me, and I will see everybody in the next lecture.